For the Stern-Gerlach experiment, that helped convince physicists at large that even subatomic particles like electrons can have quantized values, in this case, a quantized angular momentum, intrinsic to its very nature. In the particular experiment, silver atoms were heated to the gaseous state and then fired in a straight line. The particular usefulness of silver, like all neutral atoms, has an equal number of protons and electrons. Therefore, there's no net charge on these silver atoms. However, unlike every subshell that appears before, silver atoms do have one unpaired electron in the highest orbital. Now, what the Pauli Exclusion Principle tells us is that no two electrons within a given atom may have the same set of 4 quantum numbers. And when we look at the unpaired electron for silver, the energy level, the principal quantum number, is 5, no matter what state that last electron is in. The orbital angular momentum quantum number is 0. The magnetic quantum number is 0. However, because that last electron is unpaired, there are instances where it may exist spin up or it may exist spin down. And that is what the Stern-Gerlach experiment made use of. By shooting a beam of gaseous silver atoms in a straight line through a non-homogeneous magnetic field, what was observed was that some of those atoms of silver would redirect toward one end of the magnetic field, whereas other sets of those silver atoms would deflect down away toward the other magnet, essentially showing that this neutral atom, there would be certain iterations where it would have one value for its magnetic moment and it would have a certain other value for its magnetic moment or angular momentum. And in the end, this showed physicists as a whole that even subatomic particles, they too can have quantized values that are intrinsic or are just the way they are by the very nature of that particle and aren't on a range or spectrum of values. And this was performed in 1922, the Stern-Gerlach experiment.